Welcome to the Human-Computer Interaction Laboratory at the University of Maryland. I'm Ben Shneiderman, and today I'd like to introduce you to the notion of dynamic queries. By dynamic queries, we mean to convey the notion of direct manipulation exploration of databases. The direct manipulation principles guide us to rapid, incremental, and reversible actions that will compose a query, and also the immediate feedback on the display as adjustments are made to the query. Typically, we create dynamic queries by having sliders that can move back and forth on the display, and as the slider is moved, the display will change, showing points of light or colored areas or text coming and going on the screen. We find this form of exploration of databases to be a lot more satisfying than the traditional approach of composing a complex query such as this one in an SQL-like format. We've implemented two forms of dynamic query. The first is the chemical table of elements, and the second one is a real estate database searching program. The first dynamic query was created by Christopher Ahlberg using the Sun Spark Station.
Every college student must learn the periodic table of elements. For this, we've developed an educational tool providing users with a dynamic queries interface to a small database consisting of the properties of some of the elements in the periodic table. It allows users to explore how the different properties interact with each other. It also allows users to find out about different trends of these properties in the periodic table. We have a slider for each of the properties in the database. That is, for example, atomic mass, atomic number, atomic radius, ionization energy, and electronegativity. On the screen, we see some elements highlighted in red. That corresponds to the red color to the left side of the drag box on the slider. These are the elements that fulfill the criteria set by the sliders. For example, right now we see the elements that have an atomic mass less than 152, atomic number less than 56, and so on. The other elements are shown in blue. Using a slider for the query is an incremental operation. As we move the slider, we have a rapid update of the screen. The operation is easily reversible. We have an easy undo function, and we don't get any error messages. So the ideas of direct manipulation very much influence the ideas of dynamic queries. Another application we can do here is to show trends in the database. We can, for example, look at the ionization energy. By slowly sliding the slider from left to right, you can see how the ionization energy moves from the lower left corner up towards the upper right corner of the periodic table. Another application would be to find breakings of trends. For example, we expect the ionization energy to increase as we move from the left towards the right in period 2. That is here. But as we slide the ionization energy sliders slowly across, we find that nitrogen is an exception. Third example I'm going to show you is that sometimes users don't know very much about the overall database, but they might have specific domain knowledge. Say, for example, that the chemist using this program knows very much about mercury, so he can move into the display, click on mercury, and thereby setting the sliders to the values of those properties of mercury. From there on, he can make his query less selective or more selective to get more or less elements highlighted. To show that dynamic queries is an effective way of database search, we run a usability study. It showed us that chemistry students answering questions using a dynamic queries interface answered in approximately half the time compared to those using an old textual interface. Another application of dynamic queries is home finding. For this, Christopher Williamson have built a tool on the IBM PC.
Finding a home is a challenge with current information tools. Newspaper provides a vast array of homes with little or no organization. Realtors offer huge listings, sorted maybe by one field. Recently, some realtors have offered personalized home searches. These are a vast improvement over previous information tools, but they're rather long, complicated forms. You fill it out, turn it into the person behind the counter. they return it only to find that one home satisfies your query. You fill out the form again, this time getting 200 homes back. The dynamic home finder utilizes dynamic queries to help combat this all-or-nothing phenomena, as well as empowering the prospective home buyer with a new and more powerful information tool. Typically, again, this system will be running on a touchscreen kiosk to help convey the direct manipulation idea of sliding the sliders with their finger. However, since it'll be easier for you to see, I'll be using the mouse for this demonstration. Now, let's take a hypothetical situation where Dr. Jones, recently hired by the University of Maryland, is interested in finding a home in the Washington, D.C. area. She would select the location she's interested in working at by dragging the A icon here across the map up to the location where she'll be working. In this case, near the University of Maryland, located here. Next, she would drag the B icon down to where her husband would be working near the Capitol downtown, about here. Next, she goes over to the control panel and slides the distance marker to how far she's interested in commuting to her office at location A. In this case, she's interested in bicycling to work, so she's going to slide it up to 5 miles. She's not interested, her husband's taking the metro, and it's not very important to them how far he needs to commute to the house, so she slides that all the way up to the top to signify she's not interested in searching on that field. Next, Dr. Jones is interested in a home with at least 4 or more bedrooms. She designates this by sliding the slider bar down from 9 to the indicator reads 4. This means she's interested in a home with 4 or more bedrooms. If the house had 5 or 6 bedrooms, she would just have a guest bedroom or a study. That would be fine. Next, she's interested in a home that costs in about the $80,000 price range. Okay, again, designated here by the indicator $80,000. Finally, Dr. Jones is not interested in any apartments or condominiums, only in houses. In this case, as you can see, Dr. Jones has produced a list of approximately 7 homes here. She might be interested in having a printout of some more homes, so she could do this by simply deciding that she's interested in paying a little bit more for a home, and now she sees that when she slides up to 100,000, several more homes are available at that price. And finally, she could also choose that, well, she's actually interested in, she would rather not have to bicycle 5 miles, she'd rather be able to bicycle less, so she can actually slide that down to only 3 miles, and here she's got 2 homes, but she's going to go ahead and select 4 miles. That's a reasonable set. Now she's dealt with the all-or-nothing phenomena by only having about 8 or 9 homes is what she's interested in. She can find more information on a home by selecting it, and down here on the bottom of the screen is the specific information of the home. And conceivably at this point she could select a print button and get a listing of the detailed information of these homes, or even get a video tour on video disc at the realtor of these specific homes. Finally, she can manipulate a proximity query by dragging the A on the screen. It would be almost difficult, if not impossible, for a text database to offer this service. Here, for example, I've dragged the A to a new location where Dr. Jones might work, and it's updated the number of houses that are also 6 miles and meet the other criteria. Since it's critical that a dynamic query be run fast in real time along with the sliders, it is important to point out that this can still be done quickly with this database of over 2,000 homes on a simple PC. Here there are over 2,000 points of homes with different criteria, and yet it can still be queried in real time with the sliders.
These 2 dynamic queries reveal the power of direct manipulation exploration of databases. In building these interfaces, we came across many other interesting ideas that we think will lead to future improvements. For example, we'd like sliders that have both upper and lower bounds that can be set by the users. We'd like Boolean combinations of the sliders and other selector fields. Also, as the database gets large, we will need to do more rapid searching and possibly parallel computing to search the database and display the results rapidly enough. However, we've been very encouraged by these two implementations and feel that there's a very promising future for the concept of dynamic queries, both for novice users to give them easy access and experts in the domain areas so that they can explore and develop intuitions about a database, which would be very hard to do with any other method than dynamic queries. Thank you.